is my favorite subject and a very challenging class. And if you ever take it, you should do more than just pass.
So as we go to the right, the numbers are positive infinity on the x-axis, and as we go to the left, they are negative. And how about on the y values? If I go down, is that positive or negative numbers? So negative infinity and positive infinity. Alright, let me explain this language here. This language here is called end behavior. It's asking what's happening at the very ends of our graphs, basically where the arrows are at. Let me explain this. This one says, as x approaches infinity. So on the x-axis, if I go towards the positive infinity, remember it doesn't have a plus sign, it just means there's no negative. Is that left or right? As x approaches positive infinity, this is going towards going from left to right. In this graph, what happens to our graph as we go towards the right? Does it go up or down? The graph goes up. So f of x is a fancy way of saying y. Go ahead and write that. F of x is a fancy way of saying y. The y numbers, the numbers on the graph are going up. Now this one says as x approaches the x-axis, as we go towards negative infinity. Which direction is that, class? That is going from right to left. Do you see that? So as we go from right to left, what's happening to our graph? The graph is going down. So that means the f of x or the y values are going towards negative infinity. So this means down. So to summarize, this one is going from left to right. What's happening to the graph? It goes up. And this one, as you go from right to left, it is going down. Question A1 tells you to sketch the graph of the function and describe the end behavior. So sketch is a verb, that's the first thing, and describe is the second verb. I recognize that x to the fourth is an even. It's an even number, so they call this an even degree. Even degree, the easiest one we know, easiest, is x to the second. It's just a parabola, starts up, ends up. So mine's going to do the same thing. Now later in questions 5 and 6, you might want to look for the leading coefficient. A leader is always in front. A leading coefficient is either positive or negative. So my graph's going to look something like this. Remember, the higher the degree, so if it was like 10, 20, or 40, it's going to become more flat near the origin. Now for my end behavior, we always put this yellow box here. As x goes to the right, positive numbers. And remember, the yellow box is always the same, one positive, one negative. As you go towards the right, what happens to the graph? Goes where? Up. And as you go towards the left, what happens? It also goes up. My end behavior is towards positive infinity. Notice how these are the same, and then my arrows are also the same. Remember, end behavior is just talking about the arrows. Joseph. A2. Sketch the graph of f of x. I have an odd number. This odd degree, the easiest one is x to the first. Start down and up. So I'm going to start down and up. I'm going to go through the origin. And as the numbers, odd numbers get bigger, it's going to become more flat here at the origin. So that was called sketch the graph. Now let's describe the end behavior. Then you just fill out the sentence frame. Remember the yellow box? It's always the same. One has to be positive and one has to be negative. This says as the x goes to positive infinity, that just basically means it goes towards the right. What happens to your graph? Does it go up or down? How do you say up? Positive infinity. And as you go towards the left, what's happening? It's going down, so that is negative infinity. If you think about it, odd degree functions are always one's up and one's down, so those will always be different as well. For A3, it tells you to sketch the graph of f of x and describe the end behavior of the graph. So sketch and describe. Question number 3, I recognize that 20 is a even or odd? Even. And the easiest even you know is x to the second power. What does that look like? It looks like a parabola. What's important is that the arrows start up, ends up. Now you have to look at the leading coefficient. If there was a positive or negative here, that would flip these to the other side of the x-axis. And as this number keeps getting bigger and bigger, it gets flatter near the origin. Now it says to describe its end behavior. So now I'm going to use a sentence. Remember, in this sentence, the yellow box is always the same. As x goes towards the right on the x-axis, the positive numbers, what happens to our graph? And how do you say up on f of x? Positive infinity. This second sentence says as you go to the left on the x-axis, what happens to our graph? Up or down? And how do you say up? Positive infinity. Alright, let's go over question number A4. The directions tell us to, in the end behavior here, sketch the graph of f of x, so you have a visual, and then describe the end behavior. What is this end behavior here? This sentence right here is your end behavior sentence. End behavior sentence. So you should be writing that every single time you see the word end behavior. Okay? Alright, so how do I graph x to the 25th power? If you circle the exponent, this is an odd degree. Degree is another word for exponent. Well, what's the easiest one, do you know? That's odd. That would be x to the first. How does x to the first help us? You have a graph that's a line, and basically these arrows, notice how it's bottom left, top right. Watch this, bottom left, top right. How do you get a table of values? Well, this is one way of graphing it. We have our x and we have our y. If you just pick a number like 0, 0 to the 25th power is 0 times 0 times 0 times 0, so it's going to be 0. If you put in a 1, 1 times 1 times 1 times 1 times 1 is just going to be 1. But pay attention to this one. 2 to the 25th power is going to be some very large number. It's going to be huge, big. Big number. So let's graph it. 0, 0, right 1, up 1, right 2, something way up there. So our graph probably looks something more like this. And the points of symmetry, let me do that in yellow, is the same thing. Instead of going right one, up one, we're going left one. So you have this point here. Let's pick a different color, purple. And then you have some number way over there. Okay? So now you actually have an accurate where these red arrows are. Super important, these red arrows. Okay? Let's go to our end behavior sentence. As x approaches positive infinity, so that's going from left to right. I'm going to draw these. As I'm going in this direction, what happens to our graph or the roller coaster? Well, the graph finishes up. Up is positive infinity. So another way, remember the f of x is like the y-axis. Okay, so let's write our negative numbers, positive numbers, negative big numbers, positive big numbers. Okay? Let's try our next one. As x approaches negative infinity, so let's make sure we're on the same page. In this sentence, you will always have one positive infinity, and you will always have one that is negative infinity. This is telling us now, as x goes towards the negative numbers, you're going to go from right to left. Okay, let me see if I can erase my... And let's go the other direction. From right to left, what happens to the roller coaster? It ends down. So down is negative infinity. So there is my end behavior for question A4. All right, let's go for question A5. Let's read the directions. End behavior. Sketch the graph of f of x and describe the end behavior of each graph. What is end behavior? End behavior is this sentence, right? End behavior. So anytime you see this word, end behavior, you're going to write this sentence over here to the right. Oops. This one right here. Okay? So I have A5, and it says negative x to the 5th power. So the question is, how do you graph this? Well, first thing I'm going to do is figure out this one. Is this an odd or an even? This is an odd degree. Why? Because 5 is an odd number. What is the easiest odd that we know? Well, that is x to the 1st. Let's just graph x to the 1st. It would look like this. Okay? Now, what does this negative sign do? This negative sign, it flips it over the y-axis. Okay? So instead of the arrows being in quadrants one and 3, it's now going to be flipped to 2 and 4. Okay? This arrow here went over there, and this arrow goes that way. Okay? So the blue, we're going to have something that looks like this. Okay? You can just make a quick sketch. It's going to go through the origin. How do I know that? You can make a table of values. Say if they're in 0, negative, you're going to do exponents first, so 0 to the 5th power is 0, and opposite of 0 is still 0. That's why it's still going through the origin. If you did something like 1, 1 to the 5th power is just 1, and opposite of 1 is negative 1. If you went, let's do a different color. If you do 2, negative, remember it's not negative 2, it's 2 to the 5th power, which gives you 4, 8, 16, 32, and opposite of 32 is negative 32. So you'll have 2 and some really number way down here. Okay, let's erase this. So the big idea is that it's going, these blue
arrows. The arrows are what helps us understand the end behavior. Okay, so now we have a visual. Now if you get stuck on that, you can just use a graphing app. I have Desmos, and I'm going to type in subtraction x, and then you can press a to the b power to the 5. Okay, and there you see our graph matches. Okay, so what does this end behavior sentence work? As x, so this is the x-axis, as we go towards positive infinity, so this would be on the x-axis, negative numbers, positive numbers, negative numbers, and positive numbers. But we're only referring to, let's see if we can make this clear, this sentence here, let's try and make that bigger, this sentence here only refers to just that axis right there. So as we go from left to right, what's happening to my graph? Well, I can draw these lines. So as I'm going towards this direction, what happens to that arrow? The arrow is going down. So it says f of x, or the y values, are going down. So we're going to write negative infinity is my answer. Okay? All right. So we can use these. As x approaches negative infinity, okay, so now we're going from right to left. We're going from this direction to this direction. We're just going to notice what's happening to our graph. So we go in this direction, we'll see that the graph finishes what? Up. So let's write that. We finish up, which is positive infinity. So there, filling out that blank there is essentially your end behavior.
I love math. You don't love math? What's wrong with you? I love math.
All right, let's go over question A6. End behavior. Sketch the graph, so that's the first one you thing to do, and then describe the end behavior. What is this end behavior here? It basically just refers to the arrows, and I'm going to write it right here. End behavior. It's not how you start in life, it's how you end in life. End behavior, right there, okay? Let's first graph negative x squared, okay? Let me do some pencils, it's a little bit lighter. What is x squared? X squared, and its degree here, this isn't even or odd. It's an even, so we call this even degree. What is the easiest even degree we know? Well, we already have it right here. And this one looks like, remember, if you want to graph it, you can just do something like this. 0, 1, 2, and then you have, again, I'm just graphing what's in the blue box. So 0 squared is 0, 1 squared is 1. You put in 2 in there, 2 squared is 4. So 1, 0, 0, 1, 1, and 2, 4, okay? So this is what our graph looks like. And it's symmetrical on this side, which just basically means instead of going right and then up, you're going left 1, up 1. So these would be the symmetrical points, okay? So this is what it would look like. Now, here's the bad news. The bad news is you have this negative sign. What does this negative sign do? Well, whatever your answer was, you just take the negative of that. So instead of having negative 0, and the opposite of that number goes to 0, opposite of this number is negative 1, and the opposite of 4 is negative 4. So let's go ahead and graph that. 0, 0, 1, negative 1, 2, negative 4. So what did it do? It flipped it around the x-axis. That's what the negative sign does. Okay? So when you darken that, then this is my graph. What's another way you can actually, so this one in partial blue here, this is, the blue graph is what we had before, and then once you take that negative, it flipped it. So if you go to a graphing calculator, I use this one, graph n calc 83. Y equals, press clear, clear. Then you're going to type in negative x squared. Press graph, and there is my graph. Okay? Okay, now that I have a graph, let's go ahead. Alright, so apologize that got erased, but now I'm just going to look at the end behavior. So again, end behavior, all you have to do is really just look at these arrows. Okay? Let's fill out the rest of the information there. So in end behavior, on the x-axis, these are negative numbers, and in this direction they are called positive numbers, or positive infinity. Going down is negative numbers on the y-axis would be f of x. And this is positive infinity. So the sentence says, as x approaches positive infinity. So I'm going to use my highlighter. As x is going from left to right, what happens to the roller coaster of life? This one goes down. Down is negative infinity. So let's write that. And then, let's erase these, whoops. As x approaches negative infinity. So we're going to now go from the right to the left. Right towards the left. What happens on that red blue graph? Well, it's also going down. So we're just going to write negative infinity. And a quick observation is that evens, you will have the same here. They're both negative infinity, negative infinity. Okay? See you guys.
Love math. You don't love math? What's wrong with you? I love math.
Turn in just one video, and you will be able to turn in multiple missing assignments.